So first of all, from the European perspective, what would you say are the most important achievements that the project has made?
Well, REWISE is a very ambitious project. It puts together 25 partners over almost 6 years, and we had demonstration sites in 5 different countries. We covered the whole water cycle from abstraction, even from seawater, all the way to wastewater treatment and reuse, and even covering the networks, trying to reduce leakage, trying to optimize pumping in the downstream side. The EU has given us a clear target to at least reduce fresh water use by 30%, and in addition, to improve wherever you could energy balance and carbon footprint. And we did that through various activities in all these 5 sites, whether it was in the UK, around Coventry, whether it was in Skåne with Malmö and Lund, whether it was in Posen in Poland, whether it was in Ostrava in the Czech Republic, or all across Spain, where Aqualia operates thousands of different services in water and wastewater, from Vigo in the northwest to Almeria in the southeast, or from Lleida in Catalonia to Tenerife in the Canary Islands. And we did manage to achieve most of these targets, reducing freshwater use and improving the energy balance of our water cycle.
Mm. Is there any specific result that you would like to highlight?
Indeed, if we go to Spain, where water scarcity is our main preoccupation, at least in the south of Spain and in the islands, we did work hard on desalination to reduce the energy need. Desalination today is one of the most energy intensive water treatment processes. It takes about 4 kilowatt hours per cubic meter, 10 times more than any other process to separate the salts from the water. And we did manage to get that down as well by 30%. In addition, we managed to harvest the brine. Today, the brine, 50% is normally put back into the ocean, but you can actually use that brine as a chemical raw material. And we extracted salts and magnesium from that brine and therefore also improve the energy balance. On the other side, on the wastewater side, on the reuse side, we developed the anaerobic membrane bioreactor, which is an energy self-sufficient water reuse system. You can separate wastewater through a membrane, concentrate the wastewater and the bacteria to be more energy efficient, to produce actually methane from the raw wastewater. So at the same time, you produce reuse water and biogas and have a self-sufficient system that then can be used in a flexible way as a what we call sewer mining. You can use that little box, put it, if you have a sewer and you have some water need, put the little box into the sewer, produce energy and produce water, maybe for an industrial building, for a cooling process, or for irrigation in a self-contained way.
Mm. Wow, that's impressive. So I'm wondering a little bit about the Skåne Living Lab. What would you say are the most important contributions that has been made from this part of the world?
Well, Skåne from the beginning was very clear in their focus. They wanted to achieve the aim of reducing freshwater use through rainwater harvesting, and they came up with a variety of solutions, whether it's in the parking garage or whether it's using rainwater in the buildings for toilet flushing or for washing machines. It meant that not only you needed a technical solution, but you also needed a joint effort of all interested parties. This is what we call the stakeholder input. You needed administrations to work, the health agencies to work together with the municipal governments, and of course with the technical researchers from the universities and the water companies, and together agree, even with the users of the infrastructure, what was the right solution. So I think that was very, very interesting, both the variety of technical solutions and the integration into a real world solution in 5 sites is very impressive. I have another more personal preference for Skåne, because one idea I like a lot is the urine harvesting, because I know that artificial fertilizer production today in the world is one of the most energy intensive, one of the most carbon footprint intensive industries. On the other side, we are all fertilizer producers. And if we could only manage to concentrate this 1.5 liters of fertilizer we produce, instead of flushing it away with 150 liters of drinking water, we would, of course, contribute to a more sustainable world. And I think the work that was done in Skåne by testing the urine separative toilets, by producing already a fertilizer on site, is a very valuable contribution. It might be more difficult to implement because the buildings are not easily configured, but if you can put it into certain situations like a soccer stadium or a big concert event, then it might be a good contribution to a more sustainable world.